To graph a quadratic function using the axis of symmetry, first, find the equation for the axis of symmetry. This will allow you to locate where that parabola is along the x-axis. Then, find the vertex. Then choose easy numbers on one side of the vertex only. Not both sides anymore, just one side of the vertex. And then this word, reflect the points across the axis of symmetry. So I've been talking about how there's this axis of symmetry. One side of the parabola is exactly the same as the other side. We can take the points that we find on one side and pretend that the axis of symmetry is a mirror and reflect those points through that mirror to the other side. And now that saves us even more math that we have to do. Then draw in your smooth curve. So this is like all the shortcuts all at once right now. Graph this function, f of x equals x squared plus 4x plus 3. First thing we're going to do is find the axis of symmetry. So I'll write down AOS, x equals, we need to remember the axis of symmetry, the equation for that is x equals negative b over 2a. And again, this is a, this is b, this is c. So what do we have for the axis of symmetry then? Negative 4 over 2 times 1. So that's negative 4 over 2, which reduces down to negative 2. Yeah. So the axis of symmetry is x equals negative 2. So now I can draw in that axis of symmetry on my grid right now. So here's negative 2, which means my axis of symmetry is sitting right here. Which means my parabola is centered around this axis of symmetry, whether it opens up or down. By the way, does it open up or down? That's a positive A, so it opens up. So somewhere in here I have a parabola kind of doing this. Maybe it's up here, maybe it's all the way down here, I don't know. That's what step 2 says, find the vertex, so that at least I know where this thing is. And then choose easy numbers on one side of the vertex. So we're going to set up a table. We can't avoid setting up a table here. We still have to set up the table. X, my function, x squared plus 4x plus 3, and then y. I have to find the vertex, which means I have to plug negative 2 in to my equation. So I'll put negative 2 on there. That'll be the first point I find, and that'll be my vertex. Now, step 3 says choose easy numbers on one side of the vertex. So my advice to you is to pick the easier numbers on one side of the vertex. So we have a choice. We can pick the numbers on the left side of the vertex in this case, which would be negative 3, negative 4, negative 5. Or we could pick the numbers on the right side of the vertex, which would be negative 1, 0, and 1. Which ones sound easier to work with? Negative 1, 0, and 1, absolutely. So I'll go negative 1, 0, and 1. I don't have to pick anything else. So now, step 4, or choose easy numbers on one side of the vertex. We've got to find those points now. So we go negative 2 and plug it in. Parentheses, well, we got negative 2 squared. What is negative 2 squared? It's 4. So I can just write 4 there. I can do this math in my head and then write down each term. Then I got negative 2. I plug it in here. Negative 2 times 4 is negative 8. So I write down minus 8. And then I got that plus 3. So now I have negative 4 minus 8 plus 3. 4 minus 8, what is that? Negative 4 plus 3 is negative 1. So now we take negative 1 and plug it in. What's negative 1 squared? 1. What's negative 1 times 4? Negative 4. And then the plus 3. So we have 1 minus 4. What is that? Negative 3 plus 3 is 0. Okay, now I plug in 0. What's 0 squared? What's 0 times 4? So what do I get here? 3. That's an easy one. What is that one, by the way? 0, comma 3. What is that? Yeah, that's the y-intercept. We actually knew that one already. We knew right off the bat that the parabola crossed the y-axis at 3. We didn't even have to put 0 in. We knew that one without doing any work. So let's do 1 and then we'll be done. 1 squared is 1. 1 times 4 is 4. And then plus 3. What do we get total? 8. Okay, now let's plot these points that we have. We have -2, -1. That is right there. What is that point that I just put down? That's the vertex. I have no choice. I have to find that one. Now -1, 0. -1, and then 0 is right there. And then 0, 3 I already graphed. And then 1, 8. So here's +1. +6 is here, so +7 would probably be there. +8 is slightly off my graph, and we know that that's okay to put a dot all the way up there. Do I have the whole parabola here? No, I don't. But what I can do is what step 4 says. Reflect the points across the axis of symmetry. So think about this for a minute. If you are standing in your bathroom in the morning, and here's the mirror right in front of your face, and you're looking into the mirror, what do you see? You see your reflection. Where is your reflection? Well, obviously it's in the mirror, but where? Is it pressed right up against the mirror? Do you look in the mirror and you see your face smashed into the other side of the mirror? No, where are you in the mirror? You are the same distance away from the mirror. And are you directly across from yourself, or are you more like floating off into space somewhere else? You're directly into the mirror. You look straight into the mirror and you see yourself looking back at yourself straight through the mirror to the other side. I bring that up because when we use the axis of symmetry as a mirror, when we look, if we were standing right here and we look into that mirror, we would see ourselves standing where? All the way over here. That's right. So we have to go 1 full square into the mirror right here, which means our reflection will be 1 full square into the mirror on the other side. That's how you reflect points over the axis of symmetry. So for this one right here, how far do I have to go to the mirror? I have to go 2 to the mirror, which means my reflection will be 2 farther into the mirror, right there. You go straight at the mirror and then continue on the same distance to the reflection. And then on this one, it's off the page, but we can tell how far that is. How far is it? It's 3. 1, 2, 3. So that means my reflection will be 1, 2, and then I got to kind of guess on that third one right there. Now do I have a full parabola? Yeah. And not only that, but I only had to find this point right here, this point right here. Technically, I already knew that one because it's the y-intercept, and I had to find that point right there. Instead of finding 7 points, I only had to do the math to find 3. And then I was able to reflect the rest of it over the axis of symmetry. I've just saved you guys like a ton of time. Cut the amount of time it's going to take to do these problems in half easily. So now we draw in our smooth curve for our parabola, hopefully going through all of our ordered pairs. As I missed that one right there and that one right there, I shouldn't have. You should be drawing that parabola all the way through all of your ordered pairs. That's the answer. Draw a smooth curve. You're done. So let's take a look at this one on the left here. I want to graph the function. Let's take a look at the function. What do we know about it before we even graph it? Give me 2 things. I see one person saying it opens down because of this negative sign right here. That is absolutely correct. And the y-intercept, somebody else said, was -2. 2 things we already know about this parabola before we even graph it. Wonderful. Now, what should we do first? Find the axis of symmetry. So, I'll write AOS, x equals what? Negative. Good. So that is -4 over 2 times -1. All right. You get negative 4 over what? Negative 2. And when you reduce that, you get positive 2. So x equals positive 2 is the axis of symmetry. What should we do next? Draw that axis of symmetry on there. Good. So x equals 2 is right here, which means my axis of symmetry is this guy right here. So I'm drawing in a dotted line, like so. So my parabola lives somewhere in here, and it opens down. Now what should we do? Make your table. All right. So we have, I'll just go over here, x and negative x squared plus 4x minus 2, and y. Okay, I need some points here. What point do I absolutely have to find? I have to find the vertex, which is located at 2 comma something. So I have to put 2 in here for sure. Now I can choose. I can go to the left or I can go to the right. Which way do you want to go here? To the left? Because to the left gives me 1, 0, and negative 1. To the right gives me 3, 4, and 5. Bigger numbers, tougher to work with. Work with the smaller numbers, easier to work with. So I'll go 1, 0, and negative 1. Well, actually, we already know one of those, don't we? What is it? Yeah, 0 is negative 2. That's the y-intercept. So I already have that dot right there. So we got one for free. Now we only got to find 3 more dots, and we're pretty much done. So we can take that 2 and do what? Square it and we get 4. So it's just 4. Get that negative sign out front. So that is actually going to be negative 4. Because what that says is negative parentheses 2 squared. So we do the 2 squared first, but then we got to multiply by that negative out front. So it becomes negative 4. All right, what's the second term? 8, so plus 8. And then minus 2. So we have negative 4 plus 8 minus 2. Negative 4 plus 8 is 4. Minus 2 is 4 minus 2 is 2. So 2 comma 2 is the vertex right there. All right, we plug in the 1. What do I write? 1 squared is 1, but make it negative, it says, so negative 1. Plus 4 minus 2. Negative 1 plus 4. 3 minus 2, 1. So I have 1 comma 1 right there. We're almost there. One more. Tricky one. Negative 1 squared. You get 1. But then it says, make it negative, so it's actually still negative 1. Second term? Minus 4, minus 2, negative 1 minus 4 minus 2, what do you get? Negative 7. Negative 1 minus 4 is negative 5. Negative 5 minus 2 is negative 7. So I have negative 1, negative 7. Does that fit on my grid somewhere? Yep. Negative 1 is there. Negative 7 is all the way down there. So I put my dot. Okay, now the table's done. What do we do? What's my word? What's my vocab word? Reflect. So do I reflect the vertex right there? No. This one is already on the axis of symmetry. So that's like if you were staring into a mirror and you pressed your face up against the mirror, where would your reflection be? Pressed up against the mirror, yeah. Nothing happens here. But this one does reflect. Where does it go? 1 box to the mirror, so 1 box again. And then this one? 2 boxes to the mirror, so 2 boxes again. And then that third one? 3 boxes, so 1, 2, I got to kind of guess where that one is. Right there. Now what? Nice smooth curve. Good. So I'll start down here, and I'll try not to get in my shadow. I usually do. There we go. AOS on this one. X equals negative b over 2a, so x equals negative what? Negative 6. Okay, and now negative 6 is 6 over, which is 3. So we know our axis of symmetry is x equals 3. What do we do now? Put your dotted line in there through x equals 3. That's right there, dotted line. Okay, now what? All right, set up the table. I'll go over here. All right. You have no choice. You have to put 3 in there. But now you do have choices. 2, 1, and 0. But 0 we already know, right? Yeah. So going with 2 and 1 and 0 makes your life even easier because you only have to find 3 instead of 4. What is 0? 4. We already got it. Okay, let's go with 3. First term is 9 minus 18. Okay, 9 minus 18 plus 4, what do we get? 9 minus 18 is negative 9. Negative 9 plus 4 is negative 5. Be careful. Plug in 2. First term becomes 4 minus 12 plus 4, negative 4. Okay, plug in 1. 1 minus 6 plus 4. 1 minus 6 is negative 5. Negative 5 plus 4 is negative 1. All right, that should be good enough. Positive 3, negative 5, my vertex. 2, negative 4 is there. 1, negative 1 is there. And then 0, 4, my y-intercept, is there. Looks pretty good to me. It looks like a parabola, so we should do what? Reflect. I got 1 here, and then 1 again. I got to go 2 here, so 2 again. I got to go 3 here, so 3 again. And I have a really nice looking parabola here. So now I can draw in my smooth curve. Should I start right here? Nope, my curve has to start outside of the grid. So I start up here. Notice where I'm at. I'm not going all the way over here. I'm up here, just above that dot, and then drawing that smooth curve. Kind of wavy there, a little shaky today, and then all the way out. There you go. That's the graph. Last problem, Emilio is competing in the javelin throw. You guys know what javelin is? If you are in track, you definitely know what it is. The height of the javelin can be modeled by this equation. And then they tell you what y and x are. Y represents the height in feet of the javelin, and then x represents the time that's gone by. So we're going to try to graph this thing. Now, these are big numbers, but we know some things about this already. Which way does this open? It opens down. What is the y-intercept? 6. Why is the y-intercept 6, do you think? The javelin is just floating? Yeah, because the person who's throwing it, Emilio, is probably 6 feet tall. That's exactly right. Good. Okay, so graph the path of the javelin. We're about to do that. At what height is the javelin thrown from? We already know that. What is it? 6 feet. There's a reason those numbers are there. And what is the maximum height of the javelin? What are we going to be using there? What do we need to find? That's the vertex. Okay, so we'll do that, but it's nice to know what it is that we're looking for before we get started. Graph the path of the javelin. We need an AOS. X equals negative b over 2a. So we have negative what? Negative 64 over 2 times negative 16. All right, so we have negative 64 over what? Negative 32, which reduces down to 2 seconds. So x equals 2 is the axis of symmetry. Now, what should we pick for our scale then? You can't have negative time. Good, so I can put my y-axis all the way over here. Javelin's just going to land on the ground, so we can put our x-axis on the bottom as well, which means we have all this space here, and our axis of symmetry is 2 seconds. So how long is this javelin going to be in the air for? Definitely 2, right? But probably not more than 4. So I got all this space, and I'm only going to be looking at 4 seconds worth of time. So how about we go every, like half a second? So every 2 would be 1. Good. So we'll go by halves, which makes this 1, 2, 3, 4, 5, 6. And this is x time, and this is height. Now we can worry about the y scale here in a minute because we don't know how high this javelin is going to go. So now what do? Right, make your table. We have x, we have negative 16, x squared plus 64, x plus 6, and we have y. We definitely have to find what? The vertex, 2. And our axis of symmetry is sitting right here. So we can go to either side. Where should we go? I can go this way and get 1, and I already know 0. So I'll go this way. 1 and 0. What's 0? 6. Now for 1 and 2, I just got to substitute stuff in. So I have negative 16 times x squared. Well, 2 squared is what? 4. So what's 4 times negative 16? Negative 64. Good. Plus, we got 64 times 2. What's that? 128 plus 6. Now we just got to add those together. Hopefully you're doing that on a calculator, or you don't have to really. You get 70. So we got to make a scale that goes all the way up to 70 at least. Now we got 1, plug that in. This one's easy. We got negative 16 here. We have plus 64 and then plus 6. What is that? 54. All right, scale 70. We can go by tens. That'll be perfect. So 10, 20, 30, 40. Here's 50, 60, 70. So 6 feet would be about right there. And then 1 second later, we're at 54, so about right there. At 2 seconds, we're at 70. So here's 50, 60, 70. And now what can we do? Just reflect. So 1, 2, 3, 4. So 1, 2, 3, 4. 1, 2, 1, 2. And that's all we have to do. We can draw in the graph of the path of the javelin. There it is. At what height is the javelin thrown from? We said 6 feet. And what is the maximum height of the javelin? It's right there. We calculated the vertex already. It's 70 feet. So to answer that last part, 70 feet. That's it.